Right. I was tempted to stop last time, but I feel I can do one more video before I stop. In the interest of your well-being. Right. Now that we understand all this estimated output, it is now time for us to talk about hypothesis testing. Now, here from your chapter 1 of Gujarat, where he lays out the structure of classical linear regression analysis, you start with the hypothesis, you make a mathematical formulation of the model, then you transform it into an econometric relationship, you gather the data, you estimate the data like we have done here, then you do hypothesis testing. So that's what we want to do, just to illustrate. Now, here I just want to show how you do it, although in class we will discuss all the niceties of the theory behind hypothesis testing. But the general idea here is that the null hypothesis denies what theory says, and the alternative hypothesis states what theory says. So we want to test the slope coefficient of education. We want to test if education has a statistically significant effect on education. So the procedure is that we state our null hypothesis, which is written as H naught, and you can write in words, or you can just write the word education, or if the original regression was written as an equation with betas, you can use the betas. So here we use words. H naught coefficient of education equals to 0. Okay, so let's start with what is called a two-sided test. Although it doesn't make much sense in the context of education because theory is very clear about the direction of the test, but here I want to illustrate various kinds of tests you can do. So what the now is saying here, by saying the coefficient of education is 0, so if you say this coefficient is statistically 0, it means you are only left with the intercept here. Education has no effect on earnings at all. That's what it is saying. Then H1 says coefficient of education is not equal to 0. I'll write not equal to 0 as this, equal sign and an exclamation mark. Otherwise you could just say not equal to 0. Okay, not equal to 0. Now so in other words, the alternative is claiming that surely education has some effect. The effect may be positive, may be negative. That's why I'm saying the two-sided test doesn't make much sense, because there is no way education can have a negative effect. But here I'm doing it to illustrate what a two-sided test will look like. Okay, then let's decide the level of significance. In this case, let's say our alpha is 5%. We are working with the 5% level of significance. Then we have to find our critical values, usually called T critical. This T critical is given by T. It will have the degrees of freedom, which is your n minus 2 in this case, because we only have two estimated coefficients, and the alpha is 0.05. Okay, this number here will appear on the two sides of the distribution, the negative side and the positive side. So you can call it plus or minus if you like. Oh my goodness, there is the trouble. Okay, so it's just t. I didn't realize that once you put a minus there, you will be in trouble. N minus 2 and 0.05. Okay, that's the structure, and we get this from the tables. Okay, now then we must state the decision criteria. How do we decide whether to reject or not to reject the null hypothesis? Now, if T observed is greater than or is greater than T obs, T critical, or less than minus T critical, reject H naught. Okay, I'll show you just now what we mean by that. Now, otherwise you fail to reject it. Okay, then what we are talking about there, which obviously you should be aware of from our discussions in class, but I can show that very quickly. Where are those drawing things so that I can draw something for you? I don't know where they are. I wanted to draw something for you so you can see. Anyway, I'll just explain it later on. Right, so then now you have to calculate the T obs, which is your statistic, and you remember that it is always your estimated coefficient over its standard error. That's how you do it. So in this particular instance, it is equal to, our estimated coefficient is this number here, and we are dividing it by its standard error there, and we get 3.58. Okay, now how do we get our T critical here equal to want to save space. We now go to our T table. Here is the T table. This is a single tail. Okay, this is an upper tail, or you can have a lower tail. If you have both sides of this distribution shaded, then we are talking about a two-sided test, because it will have a tail here and another tail here. Okay, so in the way we formulated our null hypothesis, we actually have two tails. So we have a tail this side and a tail that side. Now here is what is going to happen. Notice the note below. They said the smaller probability shown at the head of each column, the numbers you see at the top of each column there, is the area in one tail. That is like what you see there. The larger probability is the area on both tails. Okay, so let's come here at 5% here, for example, where you have 20 degrees of freedom. Here is your 20, and here is your 5% there, and this is the number. Is this a pencil? Pen. And this is the number they are talking about. Okay, and we are looking at 5% with 20 degrees of freedom. That's the information they explained. So now, to get the critical T value for 5% in one tail, we have to go under the column with 10% here for both tails. Okay, so we know that if we have another tail here which is 5%, okay, which is 5% this side, if we have another column which is 5%, it means this 5% plus that 5% equals to 10, this number here. So then again we will make use of 1.725. There will be minus 1.725 here because we are to the left of 0, and 1.725 there, we are to the right of 0. But if it is a one-sided test, a 5% one-sided test, we look at this number on top, and again it's the same column. So what we're going to do, what we want to do is to come back to our regression. We have how many degrees of freedom do we have? We have let's write that down. We have 50 minus 2, which is 48. So that's 50 minus 2, which is 48. And here, because it's a two-tailed test, the 5% level of significance is split into 2, so that it is actually 0.025 this side and 0.025 the other side. So with that, you come to your table and you look for 50. Now 50 is a lot bigger. 48 is closer to 40 than it is to 48 is closer to 40 than it is to 60. So we are going to work with the value that aligns with 40, since we cannot find 48 in the table. And we want 5% in both tails, that is 2.5 here, 2.5 there. If we add them, we get 5%. So at the top row here, 0.025 is here. This 0.025 is area in one tail. So this 0.025, you put it there, then you need another 0.025 this side. When you add both areas, you get 5%, which you see there. Okay, so now we want 40 under that column with 0.025, and you get 2.021. That is the T critical value you need. So you come here, you write that critical value. It is 2. Did I say 021? I hope it was 021. What do we do here? .021, correct, and it is both positive and negative. Right, now if you look at, let me just try to show you what's happening. So we have two numbers here. We have minus 2.021 and we have 2.021. okay, these are the two critical limits. Okay, so if you look at 3.58, where is it? Would you say that it is bigger or smaller than the critical values? So here, this is your 2.021, okay, and this is your 2.021. This one has a negative because it's the negative side. I forget about this one. and the number we calculated is 3.5 something. Okay, what you see is that 3.5 something is far into the shaded region, which means it's far bigger than the observed t. Now because of that, we come to our decision criteria. We said that if our observed t, which is this one, is bigger than the critical t, which is that one, we must reject H naught. Okay, so what is our decision? Since T obs is greater than T critical, reject H naught and conclude that education does have an influence on earnings at the 5% level of significance. Okay, so you have confirmed that education really has an effect on the level of earnings, because the now you had said education has no effect at all, but now you are rejecting this claim that education has no effect because the evidence you found from the test says that it has an effect. Okay, right, so I will stop here, but before I do that you will probably see this thing in a two variable regression like this. Your t, this t we calculated here, is actually the same thing as the square root of the f. Square root of the f will be your t. You see that 358, 358. So that only happens in a two variable regression. There is a direct relationship between the t and the f. Then secondly, what else do I need to mention here which could be of importance? Okay, so this is our t observed, which is what we calculated there. Now an alternative way of doing that is to look at the p-value. Okay, generally we work with 10%, 5% and 1% levels of significance. Okay, now what you can do is to convert these numbers into percentages, just to convince yourself of what you are seeing. Okay, so we are much happier if the p-value we get here is smaller than 5%, or even much better if it is smaller than 1%. Generally we work with 5%. So this p-value here is much smaller than 1%. So the smaller it is, that is the closer the p-value is to 0%, the stronger the evidence against the null hypothesis. So here it is very small. So we can say reject the null hypothesis because the p-value of 0.08% is much smaller than 5%. Okay, so there is strong evidence to suggest that education has an effect on earnings. Essentially, that's the idea. So that's this one would not be significant if you are working with 5%, because look, it's 25.88%. So the p-value is the exact level of significance at which we can reject the null hypothesis. Okay, and so this level of significance there is quite strong. It's very small, which means we have very strong evidence against the null hypothesis. I will stop here.